Hello and welcome to the video. Okay, so today I'm going to go outside of my comfort zone. I'm going to debunk some flat earth nonsense. So we've all seen the meme knocking around on X at the minute. Like, it's basically Twitter chan now. Literally, like 4chan is like a ghost town. The ones that are left are just bitter and twisted over how X is taking over the place of 4chan on the internet. But anywho, enough of a tangent. So I'm going to tackle some flat earth theories, conspiracy theories, or crazy ass theories, should I say. So here I have a slice of the official flat earth map. This is Greenwich Mean Time. So obviously there's the UK, Africa, and the South Atlantic Ocean. And obviously the Indian Ocean will be around there. Right then, so what we've got is we have our little solar panel. And we also have a globe. So what we're going to look at, the incidence of photons from our sun, specifically over the period of the year. So obviously when it's winter in the northern hemisphere, it's summer in the southern, vice versa. So what we're going to do is we have, where are we? So there we go, we have our UK and Africa there. So we're going to first get our angle and get it underneath our light. Get that light nice and straight. Okay, come on, thank you very much. Right then, get our solar panel on the UK. Right, so if we look at our oscilloscope there, we have a VRMS of 740, call it, millivolts. So summertime, winter time, summertime, oh, bit more, there we go, summertime, and winter. Again, summer, and winter, and spring, autumn, and that area. So as you can see, the instance of the photons in summertime is obviously not quite directly on top, but there or thereabouts. And being the equator, we're always going to have roughly 10 degree difference in temperature there during the year. But obviously when we go to the southern Atlantic Oceans, or the southern hemisphere even, summertime, and then obviously we start to rotate round, and the northern hemisphere gets summertime. Now this is Greenwich Mean Time, so we're always going to be illuminated at any time during the year on Greenwich Mean Time. So, flat earth model. UK. Summertime. Okay, so come on, do something. Come on, do something. Why won't you do something? Okay, so what I have above is obviously a light. I did want to use a torch, another stand I've got, but I've actually got an LED gooseneck light above me, which is easy to manoeuvre. I did have a torch, which is a bit more focal, but the stand, it just wasn't good enough to do the experiment. So this is a reference to our angle of incidence during the seasons. So obviously summertime, wintertime in the UK, along the Greenwich Mean Time, all the times. Okay, so let's go for summertime, UK. Yep. Winter time, UK. Summertime, UK. And winter time. Okay. 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 Right. Get that level again. Right, so yeah. Busted. When you see these memes online and it's that, angle of incidence, it's showing, oh, how come this bit being a tiny little bit more away from the sun doesn't get as much photon energy as the equator? Well, now you know it's down to the angle of incidence. And, we don't even need all this bollocks to prove that. We can literally just rotate the solar panel. Well, you see him rotating the solar panel on a pivot with the light diameter above does not shed as much energy away or cause any less angle of incidence than when we roll it away like so with a mass like the globe in between. I remove my hand and the photons get through. Yeah, so the Earth's there. I don't need the globe to prove that, but I thought it'd be a cool thing. And, you can turn around and say, oh man, but like you used that globe, man, and oh yeah, okay, yeah, you used a kid's toy, lol. But alright, I did. But that doesn't change the straight line of photons and the angle of incidence. See, photons are that small, or elementary particles are that small. It doesn't matter whether it's a tiny golf ball or a huge mass like a planet. It does not matter. That instance of those photons reaching that object are exactly the same regardless of size. It doesn't matter. We're not shielding ourselves from raindrops here. These are tiny photons. So it doesn't matter whether it be that blow up pool toy, whatever it is. Even though it's pretty cool, it's quite detailed of the globe. But yeah, the photon energy and the direction of photons does not change. They travel in a straight line. Now, okay, I get it that sometimes through the atmosphere, the angle of incidence gets distorted and changed, and refraction happens, and all kinds of crazy stuff, depending on weather phenomenon. But I don't have a stratosphere and a troposphere here, or troposphere here, to do anything with that. And even if I did, we're talking probably that much on camera, that much. We're not really talking much, so that as a variable, although in the real world, yeah, you can physically see the beams, but the rays even on a humid day and whatnot, but ultimately what we're doing today, it wouldn't make a blind bit difference, and it doesn't make a blind bit difference on the globe either. So that is basically how a 25 pence solar panel, a print off of a sliver of the Greenwich Mean Time section of a flat Earth model, and a kid's blow up toy can debunk flat Earth, or at least how they perceive photons as hitting a globe with the angle of incidence. Okay, cool, so thanks for watching the video, and I shall catch you in the next one.